Renowned physicist Michio Kaku has just revealed an astonishing image by the James Webb Telescope. These terrifying findings have the potential to shatter our scientific understanding of the universe and change everything. What is happening? Let's find out. This remarkable telescope was specifically created to observe celestial objects or wonders that are incredibly ancient or situated at such vast distances that no other telescope can capture their presence. What it recently captured was images of 6 massive galaxies that scientists previously thought could not exist. This discovery has shaken the very foundation of our scientific understanding of the universe's history. NASA scientists have revealed that the JWST unexpectedly stumbled upon 6 supermassive galaxies resembling our local neighborhood, the Milky Way. The significance of this discovery lies not only in the fact that these galaxies are comparable in size to ours, but in their believed formation during the early stages of the universe itself. It was previously believed that such ancient galaxies couldn't be as massive as these newfound ones. The JWST provided us with remarkable snapshots, revealing that these galaxies appeared as fuzzy, unusually bright, and red dots at first. But upon closer examination, scientists discovered that these 6 colossal galaxies contained nearly as many stars as our own Milky Way, despite forming a mere 500 million to 700 million years after the monumental event known as the Big Bang. These galaxies have been aptly described as universe breakers due to the implications of their existence. If these galaxies prove to be real and not mere figments of excited astronomers' imagination, it will necessitate a complete re-evaluation of our current knowledge about the universe. One of the most intriguing aspects of this discovery revolves around the formation of galaxies, particularly the colossal ones that emerged so early in the universe's history. It challenges the very foundations we have laid in our understanding of cosmology. We now find ourselves in the position of re-evaluating our existing notions about how the first galaxies came into being, originating from small clusters of stars and cosmic dust. But how is Michio Kaku's revelation, which was an image that was captured by JWST, changing everything? The crux of the matter lies in the unexpected proximity of these massive galaxies to the dawn of time. It contradicts what we previously believed were the fundamental rules governing the cosmos. Earlier theories postulated that there simply wasn't enough time for galaxies to form in such close proximity to the universe's inception. However, it's important to note that these theories remain speculative, since cosmologists cannot definitively determine the exact moment when the first galaxies materialized billions of years ago. Traditionally, cosmologists held the belief that the process of galaxy formation would have commenced a few 100 million years after the Big Bang. But now, we find ourselves confronted with a mystery that challenges our preconceived notions. The rapid assembly of these immense galaxies in the early universe defies our expectations, pushing us to reconsider the timeline and mechanisms behind their formation. The remarkable images captured by the JWST have revealed a far more dynamic early universe than we had previously imagined. In fact, they suggest that star formation must have been occurring much earlier than our previous estimates. Before these images, it was commonly believed that it took 1 to 2 billion years after the Big Bang for proto-galaxies to form and gradually evolve into dwarf galaxies, which eventually merged to become galaxies resembling our own Milky Way. Thanks to the JWST, we have been granted the incredible opportunity to venture back in time and witness these astonishing cosmic events unfold. This telescope possesses the remarkable capability to capture light that has traveled through both space and time, allowing us to peer back into the distant past. Through this superlative piece of equipment, we have been able to observe a period in the universe's history believed to be when it was only around 3% of its current age. These unprecedented observations have shattered our previous assumptions and provided us with a captivating glimpse into the early stages of the universe's evolution. They have sparked a newfound understanding of the intensity and rapidity with which galaxies and stars were forming during that era. The JWST's ability to delve so far back in time has undeniably expanded our knowledge of the cosmos and opened up thrilling avenues for further exploration. The formation of galaxies at an unexpectedly rapid pace has compelled us to undertake a profound reassessment of our understanding of the cosmos. Take, for instance, our perception of the star formation process within galaxies like our own. According to existing theories, our Milky Way generates approximately one new star each year. Moreover, these newly discovered galaxies appear to have given birth to hundreds of stars annually throughout their existence. This astonishing rate of star formation is a key factor contributing to their current remarkable state. To further emphasize the uniqueness of these cosmic neighborhoods, it is believed that these galaxies may harbor an astonishing mass equivalent to 100 billion times that of our Sun. Contemplating this scale can easily make one feel insignificantly small in comparison. These revelations challenge the very core of our cosmological knowledge, leading us to question our assumptions. Interestingly, there is an alternative perspective regarding these mysterious objects. Some experts propose that these 6 hazy lights might not be galaxies after all. Instead, they speculate that these luminous entities could potentially be immense quasars radiating intense light, or supermassive black holes that formed billions of years ago. This alternative interpretation adds a layer of complexity to the already captivating narrative surrounding these celestial wonders, pushing us to explore new possibilities and reevaluate our established cosmological principles. The JWST has proven to be a catalyst for reevaluating our understanding of the universe on more than one occasion. Just last year, it made a remarkable discovery, an unimaginably massive object that dates back a mere 300 million years after the momentous Big Bang event. This finding rendered it older than any galaxy ever encountered before. Rohan Naidu, the astute researcher who made this groundbreaking observation, must have felt awestruck, realizing that he had just encountered the most distant starlight ever observed by humanity. This extraordinary galaxy was aptly named Glass Z13 by Naidu in the paper he published, and it captured the attention of those captivated by such momentous breakthroughs. Since the revelation of similarly ancient galaxies, our experts have been striving to keep up with these awe-inspiring discoveries. We yearn to gain a comprehensive understanding of how our universe came into existence. With the unveiling of Glass Z13, it appears that GNZ11, the previously believed most distant galaxy ever spotted, may have been surpassed in this cosmic race. The JWST continues to embark on its mission, and there is much anticipation that it will unveil more such awe-inspiring discoveries. These revelations not only enhance our knowledge of ancient eras and epochs, but also offer profound insights into our own existence within the vast expanse of the Milky Way. Change is the only constant, and it applies to our knowledge of the stars as well. The nature of the universe continually unfolds, and we can never accurately predict what new revelations lie ahead. One fascinating aspect we have discovered about the universe is how light from distant galaxies undergoes changes as it travels through space. Due to the expansion of the universe, the light is stretched, resulting in a phenomenon called redshift. This redshift is observed as a broadening of wavelengths, indicating the distance of the light source. The higher the redshift value, the greater the stretching, suggesting that the source is located far away. When it comes to early galaxies, their redshifts are incredibly high. The light they emit becomes infrared by the time it reaches our detectors on the JWST. This knowledge helps us comprehend how Glass Z13, for instance, could be dated to a mere 300 million years after the Big Bang. Its redshift value was measured at 13, highlighting the immense distance it has traveled through space and time. Contemplating this information leaves us in a state of wonderment. It challenges our preconceived notions about whether galaxies could truly have emerged in such proximity to the beginning of time. The evolving understanding of redshift and its implications fuels our curiosity about the formation and evolution of galaxies. It pushes us to question how these extraordinary cosmic structures came into existence so rapidly after the universe's inception. As we delve deeper into the mysteries of the cosmos, we eagerly await further discoveries and the transformative knowledge they bring. Some experts propose a theory that smaller galaxies could have formed during the early epochs of the universe, offering a possible explanation for phenomena like Glass Z13. However, This is just the initial stage of the JWST's mission of discovery. Building upon this breakthrough, the JWST has unveiled numerous galaxy candidates from surveys like SEERS and GLASS. These galaxies exhibit redshift values suggesting that they emerged a mere 20 to 180 million years after the Big Bang. Astonishingly, some of them possess features that were not expected to exist so early in the universe's history. But that's not all the JWST has uncovered in its quest to unveil the history of our universe. Another recent revelation has sent shockwaves through the astronomical community. A group of astronomers stumbled upon 6 faint objects near the Big Dipper, believed to have originated over 10 billion years ago. What makes them particularly perplexing is their massive size, contrary to what cosmologists initially anticipated. Moreover, these galaxies harbor billions of stars, resembling those within our own Milky Way. It is astonishing to think that they came into existence merely 500 to 700 million years after the birth of the universe. Cosmologists find this puzzling because, according to prevailing beliefs, there should not have been sufficient matter available during that early era to create such colossal worlds. In the image and video, you may notice that the dots representing these galaxies appear red. This is due to the fact that the universe is in a constant state of expansion, causing the light emitted from these galaxies to be stretched out. These extraordinary findings challenge our existing understanding of galactic evolution and the limits of what was thought possible in the early universe. If you're intrigued by the wonders of our universe, why not stay connected and subscribe to our channel? Already we find ourselves compelled to re-examine our understanding of how the universe formed. The JWST's mission holds the promise of revealing even more hidden secrets lurking within the vast abyss of space. Every discovery has the potential to leave us astounded and eager for more. For more videos like this, click on the links popping on your screen.